Hi, I'm Ronnie Remington, and I'm a PhD student at the University of Florida working on the CMS experiment.
Hi Ronnie, what are you doing here at CERN?
Well, I'm currently working on a number of activities. I serve as the administrator of a couple software packages which are used to calculate a quantity known in the business as missing energy. So what is missing energy? Well, for a given event, we expect that the energy measured in our detector perpendicular to the beams should roughly balance out due to conservation principles. If there's an imbalance in energy, then we say that energy is missing from the event. And you may ask, what could cause energy to be missing from the event? Well, there's an interesting way for this to happen, and there's a boring way for this to happen. The interesting way is if when the protons collide, we create some sort of exotic new particle that our detector just is not capable of detecting. And as a result, there would be energy missing from that. A boring way, although more common, is if the detector happens to mismeasure energy in a certain direction, which would create the illusion that there's energy missing. Aside from that, well, along with that, I have to take care of the algorithms that calculate this quantity. I have to validate them, make sure that they perform well. Aside from this activity, I also am working on some other commissioning work related to a phenomenon called beam halo, and this is particularly relevant during the startup phase of the experiment. The idea with beam halo is that we expect, on occasion, when the beams are approaching the CMS detector, that particles will stray from them, and they will end up bombarding our detector at odd angles. And in so doing, they will perhaps interfere with the detector as it's trying to record data from the intended proton collisions. It's important to measure and try to study the effects of these halo particles and mitigate them if possible. So this is another thing that I'm working on. And then lastly, I'm also contributing to the ongoing work that the UF group is doing in trying to prepare an analysis to search for supersymmetry when the LHC turns on and we understand the data.
And is this all part of your PhD work?
It is. It is all part of the PhD work.
So what's your PhD actually based on?
Well, the PhD is based on several things. It starts off with a few years of coursework, which for American grad students you do at your home institution. And then after that, you're sort of encouraged to go relocate to the lab and engage in some sort of research activities.
And this is what you're doing for a year at CERN?
Yes. Yes, and that's what I'm doing right now. I just got done with my coursework a few months ago, and I moved to CERN at about 3 months ago with my wife, and I'm starting to take on lots of research activities.
So, are you able to get data at the moment?
Well, in some sense, no, but in some sense, yes. There's data available from the CMS detector. It's not collision data. It's data from the cosmic rays. And this data can be used to sort of study the detector and study how it performs, and to sort of practice running the algorithms that will reconstruct the data. But we don't have any collision data at the moment.
So when the LHC turns on again in the autumn, then will you use the data from that for your PhD studies?
Yes, this is the plan. When the LHC turns on and is commissioned and works properly, we'll take good data that we'll understand and we'll be able to use for an analysis that you would base a PhD thesis on.
And is there anything in particular that you're looking for to prove anything in your PhD, or?
Yes, I mean the idea is that there are many theories of new physics that might be revealed by the LHC, and a grad student like myself might take on an analysis that tries to find some sort of signature of new physics. I personally plan to search for supersymmetry, but there are other areas of new physics that people could focus their research on. There's Higgs physics, and some other people at the University of Florida are working on that. There's also other exotic models of new physics that people are doing.
Okay, so you mentioned a little bit of the work that the University of Florida is focusing on for CMS. Can you just tell us a little bit more about that?
Sure. So what I've already mentioned is basically some of the data analysis work that the University of Florida is doing. On top of that, they also are very engaged in some hardware projects. They helped design and commission a subdetector for CMS called the cathode strip chambers. And there are several people in our group that are actively working on hardware-related tasks related to the cathode strip chambers. We also have several people that are working on grid computing for the University of Florida, and then, like I already mentioned, a number of people working on different data analyses.
So you're here for a year with your wife, and I understand you're living just over the French border in Thoiry. How are you finding life in France and Switzerland in comparison to life in Florida?
Well, as they say, there's no place like home, but France and Switzerland both have a lot to offer. I think where we live in a nice little village in a town called Thoiry, which is about 15 minutes away from CERN, and it's very quaint, very beautiful. And you just don't see places like that back in Florida. Switzerland also has a lot to offer, although I haven't actually spent too much time in Switzerland. But my wife and I are hopeful that we'll get some opportunities to travel in the near future.
So for other students who are looking to come to CERN to work as part of their PhD studies, to follow a career in physics, would you have any words of advice for them?
Well, yes, I think I can't really speak for other disciplines in physics, but for high-energy experimental physics, I feel like people in this field are very well trained. When you leave with a PhD, you leave with a very marketable skill set. And this is partly because you, as a PhD student, you have to take on a variety of tasks, and you have to become competent in every one of them. You have to learn how to become a proficient computer programmer. You have to learn to be an expert in statistics and data analysis. You have to, or you may learn, become an expert in electronics and hardware. And you also learn how to write publications and to present results in a crowded room full of people that are all likely to be smarter than you. Perhaps the most important is that you learn how to communicate well and work with others. With an experiment as big as the CMS experiment, which is several thousands of people, there's a lot of sociological factors involved in getting things done. So my advice would be, if you're hardworking and self-motivated and you want a very marketable skill set, then this is the direction to go.
And just to finish, you're here for a year. You'll be going back to Florida to finish your PhD. Do you have any plans for after that?
Well, I'm kind of focused on the here and now right now. It's hard to really think beyond the next year because there's a lot of challenges that we'll have to deal with, especially when the LHC turns on. It really depends on what happens with the LHC. I'm optimistic. I'm very encouraged that we'll take good data and that I'll be able to finish my PhD with reasonable time. So this is sort of what my focus is on now. And beyond that, I really enjoy the work I do. So I can definitely see myself being a career physicist on an experiment like this.
That's wonderful. Thank you so much, Ronnie, for sharing your time with us and for giving us all so much information about your work with CMS.
It's my pleasure. Thank you.